In this video, I'm going to personally draw out proposition number 16. The reason why I'm going to do this is because it's kind of complicated. Now, the first thing we're going to do is we're going to draw a triangle. Now, it doesn't matter whether it's an acute triangle, an obtuse triangle, it could be an equilateral, it could be an isosceles, it could be any kind of triangle at all. I'm going to draw an obtuse triangle. Now, this is a triangle that has an obtuse angle. And if you don't know what an obtuse angle is, go look it up, because I'm not going to sit here and explain that to you. It's just wasting time. Let's just get right straight to the point. We have a triangle. It's going to be obtuse. And we're going to start with a line about like this. And we're going to mark off on here. We've got a B. We've got a C here. And we're going to have another point called D. Now, I'll explain that in just a second. First of all, we're going to draw a line like this. And another line like this. So basically, what we're going to have in the line of a triangle, this is going to be point A right here, is we're going to have two acute angles and an obtuse. Okay, now acute angles, they're less than 90 degrees. Obtuse is more than 90. I think by now, if you've looked it up, you know what I'm talking about here. Anyway, the first thing we're going to do in this proof is we're going to bisect line AC, as you can plainly see right here, and I'm going to move this over like this just to make sure you can see this. Line AC, we're going to bisect that, and if you watched the previous video, you now know how to do this. If you didn't, you're going to watch me do it. Here we go. I'm going to turn this around like this. We're going to make two circles. They're going to be exactly the same size. And the way you know they're going to be exactly the same size, and let me just move this over a little bit. I know I'm kind of jostling the camera around a little bit. Is we're going to put one point on C. You remember how I drew circles? That was covered in a previous video. And then we're going to put the other point on A. This is a compass. This is a bow compass. And here's how we're going to do it. We're going to draw this nice little circle right like this. And then we're going to trade places. We're going to put the point on A, point on C. I'm going to draw two little circles. And that's how we do that. I'm going to set the compass aside. Now we're going to have two little points. We are not going to plot the points because it's going to make the thing, we're already going to be confused as it is, and then we're going to have more points. I don't think so. But anyway, if we were to draw the line, we would draw it from this point up here to this point down here. We're not going to do that. We're just simply going to put the point like this. And I'm going to illustrate here. This line is about 3/4 of an inch from C to this new point, which we are going to call E. And from E to A, we're going to have 3/4 of an inch. Alright, now that 3/4 of an inch means absolutely nothing because Euclid didn't measure. At least not in that way. He didn't have any numbers. He didn't like numbers. I think I've mentioned that many times in these Euclid Elements videos. He didn't have numbers, so therefore. Now we're going to draw a line from point B to point E. Alright, then Euclid wants us to extend line BE out to another point called F. And what he wants us to do is he wants us to make line EF, which is going to be a part of line BF, he wants us to make EF in length equal to the length of BE. Now, how do we do this? Well, we're going to pretend to make another equilateral triangle. Okay? We're going to take our compass here, we're going to put it on B like this, E like this. I'm going to draw another circle. I'm going to put the other point on E, point B, and actually we're going to draw this down here. You'll see why in just a minute. I'll make sure I got the circles right. Okay, so now what we're going to do is we're going to pretend to draw a line. I'm going to mark this point though. We're going to pretend to draw a line. That's why we're going to use the dotted lines. I'm going to dot line like this. And then I'm going to make another dotted line like this. Now I'm sure you've seen this procedure on previous videos that I've had. And what we're going to do basically is we're going to continue this circle right here to this point right here. Because basically what we would be doing is we would be drawing an equilateral triangle from points B and E to this new point. And we're just extending that equilateral triangle this way. And so what we do is we have a circle from centermost part B and outermost part E. We strike an arc. And we're going to put a point right here. And then from this point here way up to this point here, we're going to strike yet another arc. And I know this is making an awful lot of circles here. I'm going to have another point right here. Now, what have we proven so far? That the length of BE, which is about 2 1/4. Yeah, it's about 2 1/4 inches. It's going to be the same length as B to this other point. It's got 2 1/4 there. And so therefore, the length of E and this other point way up here is also going to be roughly about 2 1/4. Now I'm going to go over this just a little more carefully. Alright, now what we did here is we drew an equilateral triangle from here to here to here. Okay, this would have been an equilateral triangle if we'd have drawn it. We extended that equilateral triangle out here and here. Then we struck an arc using centermost B, outermost point E, drew it out to here. We're not going to label this point here because it's not going to be necessary after I get finished with this. And then we use this as a center point. This is that outermost edge. We create another circle. And we extend that circle all the way from here to here.